Okay, now in this chapter, we're going to look at pressure. Now, pressure is particularly heavy for the pure physics students, but for the combined science students, it is quite a small topic that's usually covered together with forces. So today we're going to look at the pure physics portion. Okay, particularly we're going to look at chapter 6, part C, which is on hydraulic systems. So candidates are supposed to understand and describe how does hydraulic press work. So we're going to particularly look at part C, where we're going to look at what hydraulic systems are, how does pressure come into play. Okay, so basically there are three key concepts to understanding this part, which we will go through step by step. So the first key concept is pressure in a liquid is transmitted equally throughout. Okay, now let's take a further look at the key concept number 1. Now in this diagram, we see a simple hydraulic system. Now what is a hydraulic system? It is basically a system that allows you to apply a small force that will produce a large force. Now this is particularly very useful, especially when we're talking about lifting the weight of a car so that you can change the car tires. So things like car jacks, or even like a hydraulic system for lift system, where where a simple system allows just a small force to lift 7 to 8 people through various heights in a building. So therefore, knowing the hydraulic system and how it works is very important because of its daily use and daily applications in our life. Okay, so basically, in a nutshell, what you need to know is that for a hydraulic system, it all works in the same manner, which is when you apply a small force over a small cross-sectional area, it will always give rise to a large force, provided there is a large cross-sectional area. Now, why is this so? Okay, we'll come to that in a while. So let's take a look at the first key concept first. So the first key concept, we talk about pressure in a liquid is transmitted equally throughout. Now, this is the basis of how hydraulic system work. Okay, if you take a closer look at this hydraulic system, you realize that the hydraulic fluid could be in a form of oil. It could be a form of various type of fluids. So, but most importantly, the key is you can only use liquids to fill up the system. Now, why is this so? Okay, now this is because of the way liquid molecules are placed or how they are arranged together. Now let's take a look at why the pressure is transmitted equally in a liquid. Okay, now it has everything to do with the close intermolecular distance in a liquid. So we know that the molecules are packed close together. So when the liquid molecules are packed close together, what happens is when a pressure is exerted on one end, so let's say, for example, there is a force that's applied here on these molecules on the left, and this force is applied over an area, a pressure is formed. So the pressure at A, let's call it PA, will therefore be transmitted equally throughout in all directions, simply because the molecules are very close together. So when you push on one end, the force gets transmitted and it pushes the neighboring molecules as well. And this has a domino effect. And therefore, when you apply a force over an area, the pressure that's exerted will be transmitted equally. And this means that the pressure at this point here, pressure at B, even over here, pressure at C, or even here, pressure at D, they will all be the same. So the pressure at point A will be equals to the pressure at point B, will be equals to pressure at point C, pressure at point D. In fact, it will be the same throughout, simply because the molecules are packed close together. Okay, so therefore, in a hydraulic system always uses liquid. Okay, so let's go back to the diagram. Okay, so in a hydraulic system, liquids are always used simply because of the ability to transmit pressure equally throughout. Now take note that there cannot be any air gaps, okay, in the system itself, because the air will therefore reduce its efficiency. Okay, so first and foremost, we have understood, or we have gone through the first key concept, which is pressure in a liquid is transmitted equally throughout. Now, what is the second key concept in a hydraulic system? Now, the second key concept is this, okay, which is similar to key concept number one. Pressure at piston 1 is equal to pressure at piston 2. In fact, if you understood concept number one earlier on, it will be equal in every part of the liquid. So in fact, pressure will be the same throughout. Okay, now let's take a closer look at the same diagram here. Okay, so in key concept number 2, the pressure at piston 1 will be the same as the pressure at piston 2. Now take note, how does the pressure at piston 1 come about? Now, if we recall the formula, pressure equals to force over area. So the force 1 that is applied over the small cross-sectional area give rise to a pressure. Now, because this pressure is applied in liquid, and we know that liquid molecules are packed closely together, the pressure will be transmitted equally. So the pressure at piston 2 will be the same as the pressure at piston 1. Okay, so right over at this point, the pressure, let's call it P2 over at piston 2. So the pressure at piston 2 will be calculated using P equals to force over the area. So what happens is, the moment I apply a pressure, or rather the moment I apply a force over an area, the pressure will start to be transmitted, simply because the molecules are packed close together. Now, because they're packed close together, they have no choice but to be displaced from the original position, and they push against each other, and finally it reaches piston 2, and that is how the pressure here applies a force upwards, and that is how we get F2. Okay, so the pressure at 1 will be equal to the pressure at 2. P1 will be equal to the pressure at 2. So that is your key concept number 2. Now let's take a look at what is the third concept that you need to know in a hydraulic system. Okay, now the third key concept has got to do with the conservation of energy. Okay, so assuming if no energy is lost to the surrounding, then the work done at piston 1, let's call it work done 1, will be equals to the work done at piston 2. Okay, now let's recall what is work done. Now, work done is the conversion of energy. Now, if you were to look at the hydraulic system again, the application of the force causes a form of energy when it causes the piston to move over a certain distance. So therefore, the conversion of energy from the applied force multiplied by the distance goes to the liquid. Okay, so work done simply means a conversion of energy. So if there is no energy that's being lost, then whatever energy that has been supplied at piston 1 will definitely be equal to the energy supplied at piston 2. Okay, so let's take a look. Okay, so some questions require you to understand this concept in order to apply what you've learned. So now let's take a look at work done. Okay, so as mentioned, the work done at piston 1, how do we calculate work done? So let's recall the formula. Work done equals to the force applied multiplied by distance. Okay, so work is only done, or energy is converted usefully, when the object moves in the direction of the force. So in this case, when F1 is applied over piston 1 will naturally move downwards. So if I were to draw, this will be the new position of piston 1. Piston 1 would have covered a particular distance, let's call it D1. Okay, so when I apply a force over piston 1 will definitely move downwards. Okay, so we say work is done. So therefore, the work done at piston 1 will therefore be equals to force 1 times the distance moved over distance moved by piston 1. Okay, so let's call it work done at piston 1. Work done at piston 1. So perhaps I will just indicate this as work done as well. Now let's take a look at piston 2. Now assuming there is no energy loss. Now this is important. So assuming no energy loss to the surrounding. So there is, of course, we know that this is an ideal situation. Energy will usually be lost whenever there are some moving parts. Okay, it can also give rise to the presence of friction that causes heat and sound. Okay, so but of course, assuming no energy loss, then you would know that whatever energy that's supplied at piston 1 will all go towards piston 2. Okay, so therefore, remember as we mentioned earlier, that when the force 1 is applied over an area, the pressure produced will cause the liquid molecules to exert a pressure on the neighboring molecules, and the molecules will just continue to push towards one another until it reaches piston 2. Now, this causes the piston 2 to move upwards. Okay, so I'm drawing the new position of piston 2. So naturally, it will move upwards and it will cover a distance, let's call it D2. Okay, so if there is no energy loss, then let's calculate what is the work done at piston 2. So the work done at piston 2 is force times distance, which is the force that has been created due to the pressure of the liquid, multiplied by the distance moved by piston 2. So if there is no energy that's being lost, so if there's no energy loss, then you can safely say that the work done or the energy, the useful energy conversion is equal at piston 1 is equal to the work done at piston 2. So if you were to bring out the entire formula, it will be the force applied F1 multiplied by the distance moved by piston 1 will be equal to the force that is produced due to the transmission of liquid pressure multiplied by distance 2. And this is how you solve questions. Now, of course, this is an understanding of the key concepts. The critical key is in practicing the questions, especially questions that bring about or has something to do with hydraulic systems. These are the 3 key concepts that you will need to understand for this chapter. So the 3 key concepts is pressure is transmitted equally throughout because the molecules in a liquid are packed closely together. Now, because the liquid molecules are packed closely together, whatever pressure that's applied in any part of the liquid will be transmitted equally throughout. Now, this allows us to know that the pressure at piston 1 will be equal to the pressure at piston 2. Okay, now we also know that if we apply the conservation of energy theory, that assuming there is no energy that's lost to the surrounding, then whatever energy that's supplied at piston 1 will be equal to the energy output at piston 2. And now, so this will therefore lead us to solving or the ability to solve questions using the formulas. So I hope you find this useful. So I'll see you in the next video.